Hello! Today what we're going to be doing the lab about the acid, bases, salts, or other. We're going to be testing these. We have many things that we need to test. First of all, we're going to have this sheet. In this sheet we have all these 10 substances that we are going to be testing. And we're going to be testing with the litmus paper. We're going to be testing with the hydrogen paper. We're going to be testing electrical conductivity. And then finally, we're going to be testing with reaction of the solution with magnesium. Okay? So we're going to start. We're going to start by prepping our station. First, we're going to take a piece of paper towel. On this piece of paper towel, this is where we're going to be testing our solutions. We're going to start by divvying up this paper towel into 10 sections for our 10 solutions. All right, that's done. Now what we're going to be doing is that we're going to be taking red litmus paper, our blue litmus paper, and our hydrogen paper. I'm going to cut it up into small pieces. Do the same thing with the blue. It's important when you handle the litmus paper that your hands are dry so that you don't contaminate these. And lastly, the hydrogen paper. Okay, so we have all of our solutions ready. And what's going to be very important, we remember that red litmus paper stays red with an acid, turns blue as a base. The blue litmus paper turns red for an acid, stays blue for a base. And if both of them stay the same color, they are neutral. The hydrogen paper is kind of different though. Hydrogen paper, we're going to have to compare it with the color range here so that it can give us a better idea of the actual pH. So it's a bit more specific than the litmus paper. So we're going to be comparing it with this one for all of the time. I have my 10 solutions. My 10 solutions are in pipettes right here. And I have my tweezers. So once the solutions are on the litmus paper and the hydrogen paper, that I can use this to pick it up. Good. I'm going to start with the first one. First one we have is acetic acid, okay, CH3COOH. So I'm going to add 1 drop of litmus paper to the red, 1 drop to the blue, and 1 drop to the hydrogen paper. All the times that I'm doing this, I'm making sure that the tip of the pipette does not touch the litmus papers or the hydrogen paper because we don't want to contaminate the pipette. All right, here we can see the red litmus paper is red, stayed red. The blue litmus paper turned red. And here, the hydrogen paper compare it. You can see here, I would say it's about a pH 3. Okay, so it's kind of like a pinkish orange, pH 3. And that's what I'm going to be recording in my data. Moving on to the next one, we have lime water. or also known as calcium hydroxide. So lime water. All right, for lime water, we have the red litmus turned blue, the blue litmus stayed blue, and the hydron paper. I would say it's a good 11. Let's move on to the citric acid, okay? Citric acid, C5H7O5COOH. Put it down, 3 drops. 1, 2, 3. All right, so for citric acid, red litmus stayed red, blue litmus turned red, and then here, the hydron paper, I would say between a 1 and a 2. Next solution we have is distilled water. So distilled water, so red litmus stayed red, blue litmus, stayed blue, and here, hydron paper stayed the same color. It's around 6. The edges are about 7, so I would say between 6 and 7. Distilled water should actually be more 7, but this one is maybe a bit old. Next thing that we're doing is ethanol. Okay, ethanol, C2H5OH. Okay, see again. Red litmus stays red. Blue litmus, oops, it's alive, stays blue. And the hydron paper stays the color as it was. And again, same thing, around 6 or 7. Yeah, more like the 6. Alrighty. Continuing on, the next one we're doing is hydrochloric acid, HCl. Red litmus stays red. Blue litmus is red, turns red. And then hydron paper. That one, I'd give it a 1. Moving on, potassium hydroxide. So potassium hydroxide, this one is KOH. All right, so red litmus turned blue, blue litmus stays blue, and the hydron paper. Yeah, I'd give that one an 11. All right, next one we have is sodium chloride, NaCl. Red litmus stays red. Blue litmus stays blue. And then the hydrogen paper, I'll go again, 6. Yes. Next one we're doing is sodium hydroxide, NaOH. So red litmus turned blue, or blue litmus stays blue. And our hydrogen paper is round 11. All right, last one. Sodium nitrate, all right, NaNO3. Red litmus stays red. The blue litmus stays blue. And our hydrogen paper between 6 and 7. Yep. All right, and that is for our 10 solutions, and with the litmus paper and the hydrogen paper. All right, next thing we do is electrical conductivity. We have our electrical conductivity meter here. Okay, when this electricity goes through, the light turns on. I'm going to start with our first pipette, the acetic acid, 3 drops. Electrical conductivity meter, the light turns on. It's important between each solution, you dry the probes so there's no contamination. Next one that we're doing is lime water. And the light turns on. Next one is the citric acid. And the light turns on. Moving on to the distilled water. The light does not turn on, the light stays off. Next one, ethanol. Again, the light stays off. Hydrochloric acid. the light turns on. Potassium hydroxide. The light turns on. Sodium chloride. The light turns on. Sodium hydroxide. The light turns on. And finally, sodium nitrate. And the light turns on. All right, let's clean this up. Okay, next what we're going to be moving on is with the reaction with magnesium. So first step, we have our powdered magnesium here, and we're going to be adding a little bit to each one of these test tubes. All right, all our test tubes have magnesium. So what we'll be looking for a magnesium test or reaction with magnesium is we're going to look as to if our solution actually makes the magnesium react. If we see the magnesium react, what we're going to be doing is that we're going to be doing the lit splint test to see what gas is being produced with the magnesium. As we know, the lit splint test tests for the production of hydrogen gas. So that's what we're going to be looking for. First one we're going to be doing is with the acetic acid. Okay, so what we're looking for is like here, you can see that there's all these bubbles forming. It is getting pretty hot. You give it some time. Okay, what we're going to do is now having the lit splint. Alright, so we heard an explosion, so therefore there was production of hydrogen gas. Okay, next one we're doing is with the calcium hydroxide. Now, if I'm looking inside the tube, I don't see any bubbles forming. I don't see any reaction. There's no production of heat. So we're going to put this one aside. So for this one, we're going to say no change or no observations. Next one is the citric acid. All right, right away, you can see that There was bubbles being formed. Let's see if the gas is produced. Okay, so after my lid splint test, oh, we heard a tiny, tiny little pop. Well, it wasn't as loud as the first one, but it was still there. We're going to move on to the next. There's a pop. Next one we have is distilled water. There is no bubbles formed. There's no heat. This one we can say no reaction or no visible observations, okay? No change. Moving on to ethanol. No bubbles, no visible observations. Moving on to the next one is hydrochloric acid. All right, so hydrochloric acid, you can see lots of bubbles. Let's see for the production of gas. Got our flame. All right, this one was a big pop as well. Next one we're going on with is potassium hydroxide. Potassium hydroxide. No bubbles, no heat, no visible observations. Right. Next one, sodium chloride. All right. So for the sodium chloride, no bubbles, no visible observations. Sodium hydroxide. No bubbles, no visible observations. And finally, sodium nitrate. No bubbles, no visible observations. So that concludes our reaction with magnesium. So we can see that the only three that actually reacted was the acetic acid, citric acid, and the hydrochloric acid. All the other ones, there were no reactions with the magnesium. But let's clean this up.